Hi and welcome to Quick Add Maths on the maximum and minimum values of a quadratic function. A quadratic function takes the form of fx equal to ax squared plus bx plus c, also known as a parabola, where a, b, and c are constants and a is not equal to 0. When a is 1 and b and c being 0, you would have the most basic of a parabola, where fx is equals to x squared, which is like a U-shaped curve that has a minimum at the point 0, 0. And when a is -1 whilst keeping b and c still being 0, fx becomes minus x squared. A minus x squared would have a curve that is a flipped U, and it now carries a maximum. If you now keep a at -1 and b being 0, but turning c to 10, fx becomes 10 minus x squared, with the x squared element being negative. It would still keep to having a maximum, but this maximum would move in the y direction to the value of 10. Do note that the minimum and maximum points are sometimes referred to as stationary or turning points. The line of symmetry for the parabola will cut through this point. In summary, one can identify the stationary or turning points of the curve by first identifying the line of symmetry. This we shall expand when we get on to tutorial 2. Our other option to locating the stationary or turning point is to apply the completing the square method. Knowing that x squared plus 2cx plus d is equal to the bracket of x plus c squared minus c squared plus d, we can rewrite 2x squared minus 4x plus 5 equals 0 as shown in the working to being as 2 the brackets of x minus 1 square plus 3 equals 0. Such a quadratic function has a minimum when x equals 1, where fx is 3, because the smallest possible value for an expression with a square is 0. It also means that the range for the function is fx being larger or equal to 3, and the symmetry is at x equals 1. The quadratic graph cuts the y-axis at where x equals 0, and this gets fx to being at 5. For this specific graph, it does not cut at the x-axis, as its minimum is larger than 0. Now let's take on tutorial question 1, with fx being 2 plus 8x minus 2x squared. Write the function in the form of a minus b brackets x plus c square. Also, find its maximum, then sketch the graph, and finally state the range of fx. As for question 1a, fx is equal to 2 plus 8x minus 2x squared. The next step is to simplify such that the x squared component is down to a single unit. Subsequent to this is to identify the x minus 2 square component that would replace the minus x squared plus 4x component, and further simplifying this to arrive at the required form. Having completed A, it is now easy to identify its maximum as at 10 when the expression that is squared becomes 0. This is true when x equals 2. Knowing that its maximum is at the coordinates 2, 10, and where it cuts the y-axis for when x equals 0, fx equals 2, we can safely plot the parabola as shown on the right. Finally, as for the range of the function, knowing that its maximum is at 10, it is as stating fx being less or equal to 10. Tutorial question 2. Use the symmetry of a quadratic equation to find the minimum of y equals x squared minus x minus 20. For completeness, we'll be identifying where it cuts the y-axis for when x equals 0, and this comes to minus 20, although this first portion is not truly necessary for the purpose of this question. The next portion is when we want to identify where the line cuts the x-axis, which is when y equals 0. This sets forth the equation to now being x squared minus x minus 20 to being 0, and solve for x. This comes to x being minus 4 or 5 by identifying the midpoint of these two x's, which gets us to 0.5. We can identify the value of y when x equals 0.5. This takes us to y being at minus 20.25, and therefore the solution of the minimum for the quadratic equation as being minus 20.25. Tutorial question 3. Prove by using the completing the square method that the minimum to y equals x squared minus x minus 20 is minus 20.25 as in tutorial question 2. By converting y equals x squared minus x minus 20 to being bracket of x minus 0.5 square minus 20.25, it is obvious from the equation that when x equals 0.5, this component becomes 0, and its y value, which also its minimum, will be at minus 20.25. That's all for this segment. If you found this fruitful, do look out for our other tutorials.